Convergence research is where researchers with expertise in different disciplines work together deeply to solve significant real-world problems. These are complex challenges that no single field would be able to solve alone. Pursuing an agriculture or engineering PhD or Doctor of Philosophy degree provides the type of training to contribute to and lead convergence research. Although we will focus on engineering, much of what is shared is applicable to many STEM or science, technology, engineering, and math PhD degrees. We will use examples from AgTech to show the power of convergence research. We will highlight ways in which pursuing a PhD trains people to work on and lead research projects that bring agriculture and engineering research together to solve important challenges related to farming. This video has been produced by the U.S. National Science Foundation Engineering Research Center called the Internet of Things for Precision Agriculture. The IoT4Ag Engineering Research Center unites expertise in agronomy, agricultural engineering, communications, economics, environmental science, electrical and computer engineering, cyber systems, social science, and more to develop and deploy precision agriculture technologies to address the global grand challenges of food, energy, and water security.
IoT4Ag is building integrated sensor communication response systems that capture local stresses, such as the amount of water and nutrients, and the presence of pathogens and pests over the growing season, so that farmers can predict and efficiently control the farm to improve the yield and resiliency of their crops.
People can contribute to convergence research with different types of academic degrees, including 2-year associate degrees, 4-year bachelor's degrees, and 2 to 3-year master's degrees. We focus on how students pursuing PhDs play an integral part in the IoT4Ag Engineering Research Center. Earning a PhD trains a student to become an expert in designing and executing research that uncovers novel, fundamental things in a particular area. A PhD is a formal career step that provides the knowledge and experience needed to develop innovative technologies that have great potential to benefit society, from more immediately to timescales of our children's and their children's generations. For students whose PhDs are supervised by faculty in the IoT4Ag Center, these students' research projects are critical to IoT4Ag's much larger, ambitious convergence research program. The center provides a framework for deep integration of research across disciplines that allows for creation and implementation of Internet of Things technologies that will work together in integrated crop production systems. Being embedded in one of the center's research thrusts provides an environment in which the students learn how to function effectively in multidisciplinary research teams. The teams, along with growers, ag industry partners, and other stakeholders, work synergistically towards a shared vision. Here, IoT4Ag PhD students share projects that tackle some of the society's most tenacious and significant challenges.
I design and fabricate biodegradable sensors made from paper and copper ink. These sensors can be buried under crops and provide information wirelessly on soil conditions like temperature, moisture, and nutrients.
I am developing methods to fill temporal gaps in remote sensing observations over agricultural areas through spatial temporal fusion of satellite and drone imagery. Using these methods, I seek to reduce the frequency of drone flights required for effective biophysical modeling.
I'm developing biodegradable electronics for electrochemical sensing.
I'm developing a decision support tool that enables extension educators to provide data-driven nitrogen fertilizer recommendations to corn producers across Indiana.
My work is centered on developing growth tracking models that can be deployed on field-based robots and using drone-based imagery paired with artificial intelligence to quantify fertilizer levels.
I'm developing drone-based models to estimate cover crop biomass and nutrient content using remote sensing to help farmers make timely, site-specific fertilization decisions in corn production.
I work with other IoT4Ag researchers at Purdue University to design robots that deploy sensors in our agricultural test beds and collect data on soil moisture. We are then able to send the data we collect to computer scientists at the University of Florida that design crop models to inform farmers on how to apply resources like fertilizer and water to their fields. Being part of IoT4Ag's Convergence research team allows me to travel to different universities around the country and work with scientists outside of my field of mechanical engineering.
My research fits in with the larger IoT4Ag goals because it can be applied to in-field nutrient monitoring, which would provide farmers with faster access to information about their soil. Being part of IoT4Ag's Convergent research team connects me with collaborators in different fields and across the country. The testbeds available at other universities give me access to a resource that I wouldn't otherwise have on a city campus.
My research fits in with the larger IoT4Ag goals by enabling effective, high temporal and spatial resolution modeling of important agricultural parameters, even in the absence of daily drone flights. This research is broadly applicable to joint operations at research test beds within the center that include remote sensing measurements for nitrogen application, water stress detection, and pest and disease control. Being part of IoT4Ag's Convergence research team enables me to contribute to multidisciplinary innovation across the research thrusts and joint operations, and provides opportunities to work on critical needs in the precision agricultural domain.
My research fits in with the larger IoT4Ag goals by enhancing food security through precision nutrient management that maintains high crop yield while significantly reducing nitrogen fertilizer amounts and environmental impact. Being part of IoT4Ag's Convergence research team provides me with invaluable interdisciplinary collaboration opportunities with electrical and computer engineers, plant scientists, agronomists, and industry partners, enabling real-world validation of my algorithms and ensuring their practical applicability. Thank you.
I aim to enhance the efficiency of agricultural chemical inputs while minimizing their environmental footprint. This research aligns with the broader mission of IoT4Ag by enhancing crop yields and simultaneously contributing to minimizing the impacts of fertilizers on waterways, addressing both food and water security. Being a part of IoT4Ag's Convergent research team provides valuable connections, support, and computing resources essential for translating my work into practical solutions.
My research fits in with the larger IoT4Ag goals by promoting data-driven, sustainable agricultural practices that connect sensing technologies with precision crop management. Being part of the IoT4Ag Convergence research teams allows me to collaborate across disciplines and integrate geospatial tools with agronomic knowledge, creating practical solutions that directly impact farmers and improve environmental outcomes.
Faculty members who lead research in U.S. National Science Foundation engineering research centers like IoT4Ag supervise and collaborate with PhD students who have academic backgrounds and expertise from many disciplines.
Our center's PhD students have come to IoT4Ag from a range of disciplines. In my own research group, I have students who have or are pursuing graduate degrees in electrical and systems engineering, material science and engineering, mechanical engineering, chemistry, and physics. Students who are creative, broadly curious, hardworking, and collaborative tend to thrive and be successful in our center or in other programs that use a convergent research framework.
For IoT4Ag, a critical part of making sure that our research provides real solutions for some of agriculture's most pressing problems is to bring together the technologies developed by our different research teams at our different universities. The technologies are tested together with specific crops in real agricultural fields. Our Joint Ops program brings together sensor, robotics, energy, communications, and AI machine learning systems developed by our different research teams to create integrated systems that work for a specific crop management problem, such as optimizing nitrogen and water use or mitigating losses from crop disease and pests. IoT4Ag's PhD students are at the core of the center's mission. They are the prime source of energy, ideas, and enthusiasm which powers the research and collaboration needed for such large-scale experimentation in the test beds. Dozens of students have traveled from institution to institution to deploy and test IoT for Ag technologies at scale in actual agricultural settings.
At the UCM IoT4Ag site, faculty and students in computer science and mechanical engineering collaborate in our university's pistachio and almond orchards to develop novel systems for water stress detection and management. We have hosted PhD students from IoT4Ag's other universities to come to Merced to test their sensor and robotics technologies in our tree crops. We see creative and exciting research developments. Students in our different labs at our different IoT4Ag universities come together to solve a tangible and often very complex agricultural problem.
Not only do the IoT4Ag students develop excellence in conducting research with interdisciplinary collaborators, the students are immersed in an environment that prioritizes bringing the innovative research products from the university to real growers and working farms. In an engineering research center like IoT4Ag, students interact with industry members and farmers. The students have opportunities to participate in taking their research projects from the lab to commercialization. This end-to-end systems approach, creating technologies all the way from the lab to the field and to farmers, is a pretty unique training opportunity for our center's students. Likewise, we could never develop these integrated systems that will offer farmers affordable and effective solutions without the support and outputs of our students' research projects.
If you are interested in the research and career opportunities that earning a PhD will open up for you, you will need to do some research on which universities offer PhD programs that match your background and your interests. The IoT4Ag Signature Initiative Pathway to PhD program is linked in the video description. It is a unique resource that can provide advice and help you in the first steps of writing your U.S. PhD program applications. We encourage you to think about whether more traditional, discipline-focused degree programs or PhD programs that offer opportunities to participate in convergence research are right for you.